Good afternoon. Thanks for coming today. We would like to thank Pivotal for inviting us. And today we will try to talk about Apache Geode as an efficient alternative to Kafka and Storm and Kafka and Spark. We mainly talk about Kafka and Storm. I would like to start with some about our company. Our company is named Pymma. It's a Bureau of Architecture based in London, founded in 1999. We mainly work on architecture design and software integration. And since many years, we are one of the main OpenESB contributors. My name is Perez. I'm architect at Pymma, fan of integration technology, and I have a long love story with Geode family. In the last century, I worked with Gemstone application server and also with Gemfire. I made some pre-sale for them. And since Geode became an open source project, at Pymma we try to embed some Geode feature in OpenESB. Quickly about OpenESB, some of you know OpenESB, the product. Okay. OpenESB is an integration tool, reliable, light, scalable. And it's an ubiquitous product because you can run it on very large system with dozens of instances running on the cloud, but also on very small Raspberry Pi, since we need few hundred megabytes to run our application. I would like to, in the next slide, very quickly to give you a flavor of what we can do with the product, and you will see why we try to use the Geode. Very quickly, OpenESB has been designed to work with service-oriented system. This means that on the left side, you have a process defined by the business teams and the different partners you have to invoke to create an international fund transfer services. And OpenESB can invoke, publish services, make some orchestration and composition. It has been made for that. But you can use OpenESB in different ways. For example, if you work with DDD, domain-driven design, DDD is very interesting, and it explains you that if you have a large domain, for example, what is a plane, what is a flight, you have to define different domains, airport, luggage, ticket, and each domain is viewed through a point of view, let's say. But unfortunately, DDD does not explain well how to synchronize the different domains. So when you have an update that occurs, in some cases, you have to inform the other domain. This means that airport knows the other domain. Knowledge means dependencies. And since you have dependency, you create links between the domain, and you have a kind of crystallization of your system. In that case, we can use OpenESB as an intermediate. When you receive an update, the domain sends an event to OpenESB that prepares the update for the different other domains. Another example is when you want to make some exchange between data sets. I don't know if you had the opportunity to stay a night in Paris, but in Paris you have a lot of light sources. We evaluate that in Paris we have more than 400,000 light sources, and you can understand it's a bit difficult to manage to see if the source is working or not. We can imagine a kind of process in that way. We have a street light. I switch on the light goes to a light sensor. The light sensor sends messages to on the internet, and the messages are put in a storage system. And then we use an analytic tool to generate maintenance list for the team. How could we embed OpenESB in the kind of thing? OpenESB has many connectors, so you can subscribe to an MQTT topic, and then you get the message, put them in a container such as Geode, Kafka, Cassandra, or something else. And another instance of OpenESB pick up the information and send them to a kind of intelligent event processing, and the result can go to the database to generate report and dashboards. That's the kind of thing you can do with OpenESB. So in that case, you see that we have regularly what we name our business engine. Our business engine generates events. When your process starts, when it's complete, when it's in fault, when an activity in the process starts, when the activity stops, and so on. And we can generate billions of messages every day. So our customer had the availability of these events, but they asked us 1 year, 2 years ago to create an analytic system to capture this event and then generate dashboards and reports. When we start working on that project, we found two main constraints. The first is that the event content is very poor, is raw. It's a raw message that contains what kind of event, when it has been generated, and where it has been generated. That's the first problem. The second problem is the number of events. Very quickly, when you invoke OpenESB, let's say, hundreds times per second, you can have billions of events generated daily. So it was obvious for everyone that OpenESB has not been designed for that, and it will be better to focus OpenESB resources to focus OpenESB resources on process running and process management. So we had to define an external system to process our events. For the purpose of this presentation, I have just a very simple analytic process. When we receive a message, an event process start, process complete, we compute the duration. We compute the duration for each instance of the process, and then we group them per type to have an average per second, minute, hour, and per day. We put everything on the database. It's not what we did on our project. It's just for an educational purpose. So in that system, for our external system, we evaluate that we need mainly 3 components. The first is what we named the engine. The engine must be designed for stream processing. Why? Because we didn't want to use SQL or batch system to calculate and to generate the statistics. It needs to have a good performances, horizontal scalability, and because we are Java guys, we wanted a good support for Java. The second element of this external system was the buffer. Why do we need a buffer? The buffer has to be asynchronous, and we must be able to ingest a lot of messages. Why a buffer? We didn't want to connect directly OpenESB and the engine to avoid performance dependencies between the two elements. Using a buffer, it's a way to remove this dependency at the performance level. Of course, the buffer has to be compliant with the engine, horizontal scalability, and Java support. The third element is a persistence container. The persistent container stores the information coming from the engine, and it could be any type of SQL, persistent system, SQL, NoSQL, file system, and so on. We have no time today to cover this part of our external system. So, 1 year, 1.5 years ago, when we start working on the buffer, a name came up, of course, Kafka. Why Kafka? Because Kafka is an asynchronous pattern and asynchronous system. It has a wonderful data ingestion. We had a very, very good feedback on the product. If you want to learn Kafka, you find a lot of resources on internet, white paper, course, and so on. But we found two drawbacks on Kafka, that it stores the messages on the disk and requires Zookeeper to run. When we try to find an engine, two names came, Spark and Storm. At that time, Spark was, and is today, a very active project. It relies on micro batches. But to be honest, with our knowledge, with our product, with our background, we find that micro batches were not really suitable with what we wanted to do. Moreover, at that time, I don't know if they changed it, but at that time, the Java API was complex. Spark has been designed to work with Scala. And when you use the Java API, it was not very natural, let's say. On the other side, we were impressed by Storm, that was easy to understand, an elegant architecture, but also it required Zookeeper to run. So because Storm matched our background, we decided to use Storm. So I would like to enter a bit in the detail with Storm, not because I want to do some advertising or about Storm, but I want to compare what we have in Storm and what we will get with Apache Geode. Mainly, in Storm, you have two components, the spot and the ball. The spot are used to get the information from the outside world, and the ball could be seen as an independent process, an independent Java process running. And what is interesting here is that you can define a number of processes for each of your steps in the process. Because average per second is a bit more difficult, we assign 3 balls for that step. And once the ball calculates the average, we send them in a persistent system. So if you want to see what is exactly the communication between two balls, it's a chain of queue, executor, queue, executor, and so on. So we developed our proof of concept with Kafka and Storm, but also with Kafka and Spark. But we put the Spark proof of concept aside. And to be honest, it worked well. We made it in a few weeks. It provided good horizontal scalability. But installing this kind of product in a proof of concept and on production is two different things. You need skills on Kafka, on Zookeeper, and in Storm. Why? Because you want to reach the quality level for a production environment. And when we offer this chain to our customer, they say, no, thanks, too complex for us. We have to find a guy for Kafka, a guy for Storm, for Zookeeper. So they ask us to find a simpler solution. So we searched a simpler solution, and because we had the background with Geode, we said, why not Geode? It will be a good thing. We tried to search a kind of all-in-one product to replace the buffer and the engine. Apache Geode has a good ingestion, horizontal scalability, and overall, it has an event framework that can compete with Storm, and it's what we will talk now. So if we want to compare Kafka and Apache Geode for our project, I don't say for all the other projects, but for our project, we had mainly the same feature. We found that Apache Geode was a bit simpler to understand. It did not require an additional product. But our colleague and friend said, yeah, but you store your data in memory. It's fast. It's faster than the disk. but you are limited in memory. You say, yes, we are limited in memory with few terabytes. We just need few gigabytes for our project. So it was not a problem. It became more challenging when we say we wanted to replace Storm by Apache Geode. Why? Because people think that Apache Geode is just a distributed cache. No, it's something more. Apache Geode contains embedded a complete event framework, synchronous and asynchronous. And we will talk about the asynchronous one. Moreover, Apache Geode does not require additional product. It has no single pole of failure, no congestion point. And as an architect, one of the key points on Geode is that data and process collocated in the same product. So, very easy. The asynchronous framework is as follows. When OpenESB or any other product send a message to a region generates an event. The event goes to an asynchronous queue, and when the queue is full enough, the events are sent to an handler. It could be also named a listener. It's a process Java. It's a Java process. And then the handler is able to process the event and then generate another message for the next region. And the next region generates an event for a queue. So we have the design here is similar to the one we defined in Storm. And the analytic process we defined could be smartly divided in steps. How to do it? Very easy. You have to create an asynchronous queue, link the asynchronous queue to a listener, and when you create, and you associate a group to the asynchronous queue. And when you create a region, you associate the region to the group, and then you associate the listener to the region and the queue to the region. You can see that I put this parameter in bold because we will talk about that now. You have, for the parallel parameter, true or false. Let's say in false. Example false. Parallel false means we are in a serial mode. This means that if you have partitioned region here, and you put one region per machine, one and only one queue will be created in your system. It is made to keep the even order. Of course, you understand that it's possible to create a congestion point. When you work in a parallel mode, for each instance, we create a queue and an handler. Geode creates a queue and an handler. And in this parallel mode, we can create an horizontal scalability since you create more resources for processing your step. So when you have a complete process with a step 1, step 2, and step 3, it is very easy to get a scalability by duplicating your machine. So this works, of course, only if you have partitioned region. I will not talk about the difference between partitioned region and replicated region. Okay. So partitioned region improves the horizontal scalability. The scalability is mainly automatic. Okay. We have a bonus also, because if you use partitioned regions, you duplicated your entries. But duplicating an entry does not mean you duplicate an event. Geode guarantees that you have once and only, the event is generated once and only once. Okay? Now, let's go a bit deeper in scalability. Have a look on these two pictures. We can see that Storm scalability is provided by bold redundancy. In my pattern, Geode scalability is provided by process redundancy. This means that I don't know if we say that in English, but the scalability granularity is finer for Storm than in Geode in my case. And if we want to get the same granularity, the same level of granularity, we have to make an additional effort in the design. Suppose you have to increase the number of handlers for your step 2. In that case, you can add 2 new machines. But adding reagent or adding machine could be an opportunity to increase the scalability of a step. So you get a better granularity for your system. But this solution stops you to improve the collocation. I will suggest you to see the presentation given by Murex last year, where he explained that moving from one machine to another one has a cost because you go through the network. So it is up to you to decide, excuse me, I made a mistake. It is up to you to decide how do you want to design your scalability. The first pattern I give you is very simple and works well, especially if you create a collocation between the region. But the collocation is beyond the scope of this presentation. If I will have 2 hours, it will be possible to talk about that. Okay. So, conclusion. On one side, we have Kafka, Storm, Zookeeper. On the other side, we have Geode. On both sides, we have very good performances. With our project, with our machine, with our background, we get mainly the same result, maybe 10 to 20% more for Apache Geode. But the deployment was far complex on the left side. Regarding the scalability, as I show you, scalability is very easy. You have just to duplicate your process. For Kafka plus Storm plus Zookeeper, you have to combine the scalability of Kafka, of Spark, and Storm, and Zookeeper. From our point of view, Apache Geode was the best solution. Why? Because it was not rejected by our customer and was simpler to develop. So, as I explained, Geode has a unique design. Data and process collocate in the same environment, and we have an ultra-fast exchange between the data and the process. In our project, with our background, we evaluate that Geode overcomes Kafka take separately and Storm separately, alone. If we put them together, we get mainly the same level, but we found that Apache Geode was simpler, and it became our first choice for that project. Thank you very much. If you have any question and comment.
Questions?
So you mentioned that the amount of data that you were moving in the system was in the order of gigabytes, right?
Could you speak slowly for me?
I'm sorry. Yeah. I said that you mentioned that the amount of data that you were moving in the system was in the order of gigabytes, correct?
Gigabyte of memory.
Memory. Okay.
That's what. Because we have a streaming, so we generate. We work for a customer that had around 30 instances of OpenESB that generate events, and they have, I think, 6 billion of events every day. The event is a small string, but it was important for them.
Yeah, my question was centered around, if suppose, that you needed to scale the system up, 10 times fold, right? Would you rethink, kind of the design that you have in place? I suppose you had 10 times as much, data flowing through the system.
In any case, if you change your scale, you have to rethink about that. But what you can do, you can, if you want to stay with the same pattern, you can sort at the beginning to decide one part of my event will go there. I cannot say if I multiply by 10 because you change the scale, and maybe we have to rethink about that. But I think, why not?
Okay, that's good enough for me. Thank you.
We actually have a break scheduled for 3, but I think we can go on and eat into a few minutes of that break with another question or two. Is that okay with you? Let's do it. Question. Yeah.
What was the importance of durability in your use case? So in your use case, what was the importance of the durability of the messages? Is there any durability importance?
Sorry, I don't understand what to say.
Like the reliability, making sure that the messages are always delivered.
Okay. When you want to process billions of messages, we don't expect to have a 100% reliability. It's not of concern. Okay? We wanted to know, for example, if we had what process is the most used, if we require more hardware resources for the system, and so on. It's not one-to-one delivery. It's not the case.
All right, one more down there.
Could you explain some more about your no single point of failure?
About what?
No single point of failure. You had that on your conclusion slide.
Look, I'm not an expert of Storm. But if you type point of failure about Storm, you can see that it seems that maybe that's changed. At that time we made it, let's say, 3-4 quarters ago. We found the feedback we get from the people is that at that point on Storm, we had a single point of failure. But I can tell you. And this kind of thing, we didn't find them. We didn't find it on Apache Geode.
One more.
Yeah, here.
I have a question on your design.
Yeah.
On slide 33, you had different machines. My question, and you were connecting regions with asynchronous event processors. Yes, this slide. My question is, is this one JVM running on a single machine, or are you using the asynchronous event listeners to connect different instances of Apache Geode?
Yeah, excuse me, because I have not enough place to. Here, when I'm talking about machines, it could be virtual machine, which is JVM. Okay, so it means that you can implement your process on virtual machine, regular machine, so on. But here, it is a Java virtual machine.
I see. So different regions in the same JVM.
Yeah.
Okay, thank you.
Just to come back on one point, if we use the collocation, the arrows between the machines have to disappear, of course.